Here we are with the factoring trinomials classwork. It's going to be very similar to the factoring by grouping, just more practice with that. I'm going to continue to show the long version. If you know any shortcuts, you're more than welcome to use them. But basically, we're going to take this a value, which is 1. It has been for every example on trinomials so far. We're going to multiply it by the c value, which is 36. We get 1 times 36, which is 36. Going to make this little setup here where we know they multiply, the two numbers multiply to 36, but we need to figure out which two factors of 36 add up to negative 15. And this can be difficult. We list all the factors of 36, 1, 36. Now, keep in mind in this case, if they're going to add up to a negative 15 and multiply to 36, the only way for that to be possible is if they're both negative, because only negative numbers are going to add up to a bigger negative. And the only way for them to multiply to a positive is if they're both negative or both positive, which obviously they can't both be positive. They wouldn't add up to negative 15. So they both have to be negative. Negative 2 and negative 18. Negative 3 and negative 12. Negative 4 and negative 9. Negative 6, negative 6. And I believe that is all, yes. So I noticed that these two, negative 3 and negative 12, add up to negative 15. So those are my numbers. And again, I'm showing the long way here. You're just going to replace this b term, 15xy, negative 15xy, with negative 3xy and negative 12xy. We're replacing the b term with these, and we're including the same variables that are on the b term, and then we just put in the a term and the c term with variables. Then we factor by grouping. Group the first two, group the second two. Greatest common factor of the first group is x. I get x minus 3. And the greatest common factor here is negative 12y. Oh, I forgot the y here actually. 3y, x minus 3y, because that didn't factor out in the first group. Here I get positive x, negative 12. Negative 12 is going to be positive. And then I get minus 3y. And that's a good sign because I have the same common binomial that I need to factor out. That is going to be x minus 3y, and remaining is the x minus 12y. That's going to be my answer. You'll notice if I were just to put these in right away, I wouldn't have had to do all this work, and that only works if your leading coefficient is 1. To a lot of these initial examples, it is 1. So if you find those numbers, you can pretty much say, oh, okay, well, I know that negative 3 and 12 are my two numbers that both multiply to 36 and add up to negative 15. I can just put them in the binomials, and because I'm ending in a y squared, they need to be with a y. X minus 3y, x minus 12y. That would be a bit of a shortcut. And if you ever want to check these, you can like distribute these, multiply these back together. You should end up with your original trinomial. All we're doing is dividing the trinomial into its components. So if you multiply them back together, you should get your original. That's a good way to check your answer. Let's try number 2. In number 2, we have a situation here where I do have a leading coefficient other than 1. Now, whenever you see this, you always want to ask yourself, can I GCF? Or is there a greatest common factor between all three terms? And if you know your factors of 6, your multiples of 6, you'll see that, yeah, 6 is the common factor there. So I can take out the 6 and end up with u squared. 24 divided by 6 is 4. Still have the u. 36 divided by 6 is 6. Now I have that 6 factored out, so it's reduced to u squared minus 4u minus 6. And then we want to see if we can factor that. What are the two factors of negative 6 that add up to negative 4? One of them would have to be positive, one would have to be negative for them to add up to a negative and multiply to a negative. So I've got, for the multiples or factors of 6, 1 and 6, 2 and 3, And that's it. This is a rare case where there are no factors that multiply to a -6 and add up to a -4. It's very rare, so don't give up on all of them because there usually is a factor. But sometimes there's not. So this is going to be my final answer here. 6 times u squared minus 4u minus 6. If you're not completely factored on the homework, then you can be assured that Alex will obviously tell you that it's not complete, but you can just check it here to make sure that's as far as it goes. But for the test, you're going to need to be prepared to check that on your own. In other words, know for sure that it is not factorable. Or if it is factorable, you need to be able to factor it. Number 3.
Hi, Daddy.
Number 3, we have another situation here where we have a leading coefficient. Oh, hugs. I love you. Good boy. I'm going to take out a 2 because they're all divisible by 2. So we end up with w squared minus 13w minus 30. And then we need to check to see if that is factorable as a trinomial. Are there any factors that add up to -13? Let's see here. We've got the 30, -30 that is, 1 and 30. One of them would have to be negative. 2 and 15. One of them would have to be negative. That is it right there. I don't even need to go farther because I know 2 minus 15 is -13. So the shortcut here is to just leave that 2 on the outside here, and those are going to be the two numbers, w plus 2 and w minus 15, that make up my trinomial. That's the shortcut, and it only works if your leading coefficient, when you're factoring, is 1. You'll notice that this is the factored version, only has a 1. We don't write it, but it is the a term in this diminished or factored trinomial. If you want to do it the long way, if you want to keep doing that, you have to substitute 2 and 15, these two numbers, in for your b value. So you'd have 2 times w squared plus 2w minus 15w minus 30. Oops. And then we would factor by grouping there, and we get 2 times w times w plus 2 minus 15 times w plus 2, and then you would get 2 with that common binomial of w plus 2, and then we'd have a w here and a -15 here, and we get the same answer there. However you want to do it. I obviously prefer the shortcut because it takes less time. Number 4, we have a trinomial here. There is no leading coefficient, or the leading coefficient is 1. We like those ones because they're a little bit easier. So we're going to do 1 times -12 is -12. Going to find the two factors of -12 that add up to -4. -12 has 1 and 12. One of them has to be negative. 2 and 6. Oopsies. 3 and 4. And that's it. 2 minus 6 is adding up to -4, and it multiplies to -12. So those are the numbers we need. Shortcut, x plus 2, x minus 6. That's the answer there. If you want to do it by factoring by grouping, you need to take these two numbers here, substitute them in for the middle term, 2x minus 6x. You okay? It's okay. Yeah, I know. Little sicky. And then we got to factor by grouping. Hold on. Oops. X times x plus 2. Take out a -6, get x plus 2. Then we factor out the x plus 2, the common binomial, and we get x minus 6. We have the same answer there, however you want to do it. Our number 5 is the first instance here where we have this leading coefficient. It's a 3. And when we check for a GCF, which we always want to do, we don't see a greatest common factor between all three. It has to be between all three of them. So in this case, we've got to do it the long way. There's no shortcut for this one. Yeah, just one moment, okay? Be right on one moment. Just going to finish this one. Okay, so we're going to do 3 times negative 14, which is negative 42. So 3 times negative 14 is negative 42, and we have to find the factors of negative 42 that add up to negative 19. This is especially tricky because these numbers are big. But just got to list all the factors of 42. Negative 42, that is. So one number has to be negative for it to be a negative 42. We have the 3, well, let's start at the beginning. 1 and 42. 2 and 21. That's it right there. 3 and 14. 4. Nope, doesn't work. 5. Nope. 6 and 7. 8. Nope. 9. Nope. 10. Nope. 12. Nope. 11. Nope. 13. Nope. 14. That's when we start going backwards through the list. 14 and 3, 21 and 2, 42 and 1. So these are all the factors. One of them has to be negative, and it is going to be this one right here. 2 minus 21 is negative 19. If your number sense is not that great, this is a very difficult process. So that's why I always encourage people to practice their math facts. There's going to be a time in your algebra where you just have to know them. So I'm going to replace these, or the middle term, negative 19, with these two values. I'm going to have 3y plus 2y minus 21y minus 14, that's the end term, and then this is actually 3y squared. So I keep the first two terms, 3y squared and negative 14, 3y squared and negative 14. I replace this middle term with the 2y, where I have these two numbers, 2y and negative 21y, just like we've been doing in the previous ones. Okay, and I take the first group, I'm going to factor it. The greatest common factor is y, and I end up with 3y plus 2. And then I'm going to factor out here a negative 7. They're both divisible by 7. And negative divided by negative gives me 3y plus 2. No, I'm on the right track because I got the common binomial 3y plus 2. So I'm going to take that factor, 3y plus 2. And then I'm going to get y minus 7, the remaining parts, for my final answer. So my final answer is 3y plus 2 times y minus 7. Now, there is a bit of a shortcut here if you want. If you want to do it where you just plug these in here, and you get y plus 2 and y minus 21, which works if you have a leading coefficient of 1. If your a is equal to 1, you could just leave it like that. But if your leading coefficient is other than 1, then you need to divide each of these terms by it. So divide by 3, divide by 3. If the number does not divide by 3 evenly, 2 is not divisible by 3 evenly, then you have to take that number and you have to put it in front of the first term. So this becomes a 3y plus 2. Okay, and then this does divide by 3. 21 divided by 3 is 7, so I get y minus 7. I prefer to do it that way. It is a bit of a shortcut. But you see we get the same answer either way. You can also do it a third way, which is just guessing and checking. That takes really good number sense though, so I don't really move towards that unless somebody's really good with their number sense. Okay, I'm going to break this video off and make a second video because my son needs help.